If you know your 0 through 9 multiplication facts, you can multiply no matter how big the number is. You can multiply no matter how big the number is. In your journal, you have 20 by 20. You don't need it. Really, all you need is 0 through 9. All you need is 0 through 9. So we have two factors. Factors are numbers you're multiplying together. My factors are 58 and 37. The answer to a multiplication problem is called the product. So if I ask you to find the product of two numbers, that means you're going to multiply those two numbers. Product is the answer to multiplication. So on that warm-up, one of the problems said, find the product of 1,400 something and something else. That means you multiplied. Now before I do the actual multiplication, I estimate. And this is why the number talks are very helpful. Because if I'm going to estimate, instead of 58, I'm going to multiply by 60. Instead of 37, I'm going to multiply by 40. This is my estimate. All I have to know is my 6 times my 4. Then I've got these two zeros I can add. So my estimate is 2,400. My answer needs to be somewhere near 2,400. And I hope you're watching. If I can do my number talk and I know one-digit numbers, 6 times 4. If I don't know one-digit numbers, all I have to do is look on a multiplication chart. If you don't know your one-digit numbers, all you have to do is practice. I've given you several options of where to practice. Okay? You need to know your multiplication facts. Every single person in here can know them. All right, so let's look at the problem. We have a couple different ways that we can do this problem. We can do the standard algorithm. If it's written like this, you still are only multiplying one-digit number by a one-digit number the whole way through. You're multiplying 7 times 8. You're multiplying 7 times 5. You're multiplying 3 times 8. You're multiplying 3 times 5. None of what I have to do is bigger than a one-digit number times a one-digit number. So we'll come back and do the standard algorithm. They call this, I don't know, some people call it the box method, some call it the something else. Okay, 58. I decomposed 58 into 50 and 8. Go that way. I take 37. I'm going to do the same thing. 30 and 7. I'm still going to multiply 3 times 5 and 3 times 8. 7 times 5 and 7 times 8. So the hardest problem you have to do is 7 times 8. My guess is that'd be harder than 7 times 5 or 3 times 5 or 3 times 8. I'm guessing that 7 times 8 is going to be the hardest one you have to do. But you all have access to a multiplication chart if you need it. The number talks help explain when we have these zeros at the end, when we have the trailing zeros. All I need to know here is what is 5 times 3? Anybody? 15. Then I have these two trailing zeros. So 1,500. What's 3 times 8? Anybody? 24. And I have 1 0. So 240. What's 7 times 5?
350.
Okay, so it'll be 350, but 7 times 5 is 35. So make that 350. 7 times 8 is what? 56. Nothing that I did was more than a one-digit number times a one-digit number. Nothing that I did was more than a one-digit number times a one-digit number. Now it's just adding. I add what's in the boxes. 1,500 plus 240, 350, and 56. Now, if I did all my math right and I add correctly, I'm going to get the correct answer, which hopefully is 6, 10, 14. Let's see, 5, 10, 11. So 2,146. If I did all this math right. I'm not saying I did. I was depending on you for this stuff. And then I was depending on me for this, and I'm not very reliable sometimes. But again, all we did is 1 digit by 1 digit. 1 digit by 1 digit. 1 digit by 1 digit. So don't ever tell me multiplication is too hard for you. You're only multiplying 1 digit by 1 digit. And I might say that 63 times before the end of the class period. Because I need you to get it through your head. You're only doing 1 digit by 1 digit. Here I have 7 ones times 8 ones. What's 7 times 8? 56. So that means I have 6 ones and 5 tens. That's why the 56. That's why you put the 5 up here, because I have 56 ones. Nobody wants to carry around 56 ones. So you can change it to 5 tens and 6 ones. It's the same value. Now I do 7 times 5. 35. I have those 5 extra tens, so that makes it 40. All I had to do is multiply 7 times 8 and 7 times 5. You're only doing 1 digit by 1 digit multiplication, no matter how many digits are in the factor. You could have 2,487,863,000. It could be a huge number. You're still only multiplying 1 digit by 1 digit at a time. I need to get that through your head. You're only multiplying 1 digit by 1 digit at a time. Now, I know some of your other teachers have taught you some little song while you put the 0 here. I don't like the song. I don't care about the song. You put the 0 there because you're moving into the tens place. So your first number has to be in the tens place. That is why the 0's there. What you're actually doing is 58 times 30. Because the 3 is in the tens place, so you need to do 58 times 30. 3 times 8 is what? 24. So that's 24 tens, or 2 hundreds and 4 tens. 3 times 5 is? Plus 2 more?
17.
If I add this together, 2,146. I'm going to say it again and again and again and again. If you can do zeros through 9 multiplication facts, you can multiply no matter how big the factors are. As long as you can do 0 through 9 multiplication facts, you can do it no matter how big the factors are.